All right, we get to start chapter 7, everybody's favorite chapter. So, chapter 7 is loosely based on chapter 6. There's a bunch of the skills from chapter 6 that will carry forward, but some of it will look new as well. So, the first thing that we're going to do in chapter 7 is lessons 1 and 2, where we're going to learn how to simplify and solve trig identities. So, this is going to be kind of just doing expressions or simplifying expressions within trigonometry. And then the second half of this chapter will be evaluating and solving with trigonometry. So the first thing we're going to learn how to do is simply, well, I feel like I'm saying simply a lot, simply simplify expressions. So in other words, what does it look like when you have a monomial times a binomial and they're written as trig? So for this one, hopefully you can see that it's going to be a distribution, and we're going to do sine x times sine x. And what happens when you multiply a sine x by a sine x? Well, you'll have sine x all squared. But mathematicians are way too lazy to write that. There's too many brackets and things to do. So it's a general rule that if you want to have sine x all squared, you write it as sine squared x. That's showing that this whole expression or whole term is being squared. You will never do it as sine x squared, because that would show that just the x is squared and not the entire expression. And then we're going to do sine x times cos x, and then you just literally write them sandwiched together as sine x cos x, and then this would be my simplified expression. And we're going to be doing way more with these, but this is just intro. In this second one, again, it's just a giant distribution. So we're going to multiply the cos x through, and then we're going to multiply the sine x through. You could pause the video and give this a try if you'd like. So cos x times cos x, I'm going to write that as cos squared x. And then I've got cos x times negative sine x is minus. Now, when you're writing them in order, choose an order. Do you like cos first because it's alphabetical, or do you like sine x first because everybody likes sine? I don't know. From a math point of view, I don't think it matters. I generally write it as sine x cos x instead of cos x sine x, and I think it's just because one of the identities you're going to learn shortly is written in that order, so it just feels like it flows better. So when I did cos x times negative sine x, I wrote it as negative sine x cos x, but it doesn't matter. Then I'm going to do sine x multiplied through, so now I have a plus sine x cos x. And then I'm going to multiply sine x by negative sine x to get negative sine squared x. Then always when you're multiplying a binomial by a binomial, you look for whether you can collect like terms. This one has a minus 1 sine x cos x and a plus 1 sine x cos x. And so those are actually going to cancel out, and I'm left with cos squared x minus sine squared x, which some of you might be recognizing as a difference of squares, which we got by multiplying two conjugate or complement binomials together. All those things should be in your head by the time you reach Math 60. And we will be going further with this, but this is just the beginning. So for now, we can leave it like this. If you're going back and doing your homework months later, after you've learned all of chapter 7, you might want to do more with this. So chapter 7 is big about, look at the back of the book for the answer and see if you're done or not. But at this point, that's as far as we can go. The next thing we're going to do is learn how to simplify when you're multiplying trigonometric expressions with fractions. I will say that if rational expressions are not your strong suit, I would go back and review the rational expressions essential skills if you need it. Those quizzes are multi-chances. You get 100% no matter what, as long as you keep going until you get the right answer. And they could just be a good way to refresh those skills, because I find for this stuff, it's not the new things that'll get you, it's your rational expression skills. So when multiplying fractions together, hopefully you remember that you multiply across. So this will be sine x times 1, which is sine x, and then we'll have a cos x times a cos x, which is a cos squared x, and that's good. Then you get to a question like this, where hopefully you see that you could simplify first. So this is cos x divided by sine x times sine squared x divided by cos x. So we can do it as cos x divided by cos x is 1. And then sine squared x divided by sine x is just a sine x. I'm left with 1 times sine x on the top, and then I'm left with 1 times 1 on the bottom, so I don't have to write anything. What about this one? Well, this one, it might be helpful to see it as multiplied across instead of simplifying before you go. So some people are okay with the fact that you're allowed to simplify the 1 plus sine x's. There is that rule that just be careful if there's plus or minus signs. Make sure you can take the entire expression, which you can. But some people might like it if I write it as cos squared x times 1 plus sine x on the numerator. And then in the denominator, I could have cos x times 1 plus sine x. And then you could see that these will divide to give you 1, and then cos x divides into the squared to leave you with just a cos x in the top. So cos x times 1 on the top and 1 times 1 on the bottom leaves me with just a cos x. The thing that we're going to move into next is this same idea of simplifying. So when you look at these next set of questions, you'll see it's just another distribution. But the difference will be is that all of these questions were just sines and cosines. Here we're going to introduce the tan x and the secant x and the cosecant x. So what I want you to do is I want you to go to your formula sheets and open them up to chapter 7. So as we go through chapter 7, you're going to get really comfortable with all of these identities, and you just can't do chapter 7 without these identities out on your desk. But what we're going to start with is what's called our basic identities. Our basic identities include our reciprocal identities and our quotient identities. Our reciprocal identities are the ones that we already learned in chapter 6. So these we called reciprocal trig functions, and now we're calling them reciprocal identities. And what identities are is that they are true for any value of x. So cosecant x is always equal to 1 over sine x no matter what you put in for x. So the reciprocal identities are that cosecant x is equal to 1 over sine x, secant x is 1 over cos, and cotan x is 1 over tan. The add-on for chapter 7 is that they're not always going to be written as cosecant x. They might be written as cosecant squared x or cosecant of 2x. But the reciprocal identities still hold true. So cosecant squared x is equal to 1 over sine squared x, and cosecant of 2x is equal to 1 over sine of 2x. And then your quotient identities is that the tan of x is equal to the quotient of sine x over cos x, and the cotan of x is equal to cos x over sine x. And then again, the squareds and the 2x's hold true as well. So what we're going to do is we're going to use these to allow us to simplify these expressions further. So for these ones, we literally just multiplied and then we were done. But these ones, what we're going to do is change everything into sines and cosines to look to see if anything will simplify. So for example, tan x is the quotient of sine x over cos x. So again, we're changing everything into sines and cosines. And then secant x is the reciprocal identity of 1 over cos x. Then, there's multiple ways of doing this. Some people might go, oh, look, there's a common denominator. I'll add my numerators. Go for it. Some people would say, hey, I want to distribute first and then do this. Go for it. So you kind of get to a point in math where there's like a million ways of doing it. But what we're going to do is we're going to multiply this cos x through. I would end up with cos x multiplied by sine x over cos x minus cos x times 1 over cos x. And then simplify. So I multiplied through, but now because everything's written in sine and cosines, I can do cos x divided by cos x is 1. Cos x divided by cos x is 1. And I'm left with 1 times sine x is sine x, and I'm left with minus 1 times 1 is minus 1. Don't forget, this doesn't go away. It's not 0, it's 1. All right, pause the video and give this one a try. And again, you can multiply through and then change everything to sines and cosines, or you can do that first. So I'm going to do it first. I'm going to say this is sine x plus cos x times 1 over cos x plus 1 over sine x. And now I'm going to distribute. So the first one I'm going to have sine x times 1 over cos x. Or some people might go straight to sine x over cos x. For the second one, I'm going to have sine x times 1 over sine x. Then I'm going to multiply the cos through. So plus cos x times 1 over cos x. And then cos x times 1 over sine x. Then I'm going to simplify. So for this one, there is nothing that can simplify, so I'm simply going to multiply across. I end up with sine x over cos x plus sine x times 1 over sine x. I can just go sine x divided by sine x is 1, so I'm left with plus 1. And then cos x divided by cos x is another plus 1. And then cos x over 1 times 1 over sine x will give me cos x over sine x. Now I'm going to collect like terms, and I could write this as sine x over cos x plus 2 plus cos x over sine x. And that could be a great answer. But you might look at the back of the book, and the answer is tan x plus cotan x plus 2. And in chapter 7, especially lesson 1, you have to be okay that it could be either of these. They're both great. So what will happen on the test is I'll make this multiple choice and the answers will be listed. So it'll be one of these, not both. And then you'll know kind of where to stop. And so it's important for you to recognize that it could be this, but that this could also be this. So I used my quotient identities to replace sine x over cos x with tan x and cos x over sine x with cotan x. When you're doing your homework, I highly recommend, I always do, but check your answers at the back. And if it's not what you have, think, but could I make what I have into that? Because it'll train you to be really good for what we're going to be doing in lesson 2. So on that theme, we're going to do one more question, and it's going to say which of the following is not equivalent to, just to prove to you that, every answer can have multiple variations. So I've got this expression, tan squared y over secant y, divided by 3 tan cubed y over secant y, and it's going to be equivalent to 3 of these and not the 4th, and we have to figure out which one's which. So in the previous example, the first thing we did was change everything into sines and cosines, because I knew that if I did that, it was going to make life easier. With this one, when I look at it, I have tan squared, I have tan cubed, I have secant. I'm actually not going to change into sines and cosines first. So there's no hard and fast rule with this. What I'm going to do is think, all right, if I do the division, maybe things will simplify. So when I'm dividing fractions, you flip the second fraction and multiply. So this becomes tan squared y over secant y times secant y over 3 tan cubed y. And then I look to see what I can simplify. Well, I have a secant y divided by a secant y, which would leave me with a 1. And then I have a tan squared, which will divide into the cubed to make that one a 1. So that I will be left with 1 times 1 on the top over 1 times 3 tan y on the bottom. And right away, I'm like, okay, it's equivalent to that one. Now the question is, can I turn it into these other 3? So I have one expression that has a cotan y in it, and then I have 2 more expressions that are in terms of sines and cosines. So the first thing I'm going to do is look at this as a reciprocal identity. So if we know that cotan x is equal to 1 over tan x, then we also know that tan x is equal to 1 over cotan x. So I'm actually going to replace this tan x with 1 over cotan y. I think I was saying x there, but it's y's. It doesn't really matter what they put in for the angle. So this is 3 times 1 over cotan y, so I just went straight to writing it as 3 over cotan y. Then I'm going to rewrite this as 1 divided by 3 over cotan y. So anytime you have these compound fractions where it's a term divided by a term, just rewrite it as a division so that I can flip and multiply. So this will be 1 times cotan y over 3, which is equal to cotan y over 3. So I'm equivalent to that one as well. Now we have to change everything into sines and cosines. So I could go back and I could work with this expression and change everything into sines and cosines. Or because I know that this one's equivalent, I could just keep working with this one and change everything into cosines. So I'm going to choose that. So just so that it feels like we're keeping on going and not going backwards. So I have cotan y over 3 and I want to change it into coses and sines. To do that, I'm going to look at my quotient identity, which states that cotan x is equal to cos x over sine x. So I'm going to rewrite this as cos y over sine y all over 3. And then again, is this a division? Well, it's this divided by 3. So it's cos y over sine y divided by 3, which would be the same as cos y over sine y times 1 over 3, which would simplify to cos y times 1 over 3 times sine y. So I'm equivalent to this one as well. So this would be the one expression that I'm not equivalent to. So go and practice this first part. Again, it's going to start with simply simplifying, so just being able to distribute with coses and sines, and then it'll go into a place where you're going to have some identities that aren't cos and sine, and your job will be to simplify. And one of the easiest things to do is change everything to coses and sines, but not necessarily. Don't get stuck on that.